Great. Okay. Welcome everyone to today's class on Bharatiya astronomy. I think the last few classes were conducted by Ajay ji on on the stories and the anecdotes and metaphors as it is there in our scriptures and the different texts. Today we will deal with a slightly different topic, but before that, as usual, we will start with our salutations to our Guru, Om Shri Guru Pyo Namaha, and we'll start with the Shanti Mantra. Asato ma Sat Gamaya, Tamaso ma Jyotir Gamaya, Mrityor ma Amritam Gamaya. From untruth, lead me to the truth. From darkness, lead me to light. From death, lead me to immortality. Om Shanti Shanti Shanti. Okay.
Madhu,
Uh,
you want to go to
sure.
presentation mode?
Yes. Thank you. Thank you. Okay. All right. So before we go into today's meeting, this is the penultimate class in the entire course, right? We will be ending the course uh, next Sunday, which is the 25th of January, as was the original plan when we started this course. And today we will wrap up, or we will start, and we'll also wrap up the topic of the planetary theory in Bharatiya astronomy. So that's the one topic that we have for today. And we will, as usual, have some question and answers towards the end. So just giving a heads up, in the next class, we will summarize the entire course, both Ajay and myself, and we will have some time for any question and answers that you may have had across the entirety of the course. So it will be a slightly, more extended session, probably 15 to 20 minutes more than what we usually have. So that is the plan. So with that, we should be kind of, ending the course. So today we will talk about, the planetary theory in Bharatiya astronomy, which is something that we might have touched in bits and pieces in the previous lectures, but we did not get a chance to kind of go deep into it, right? All right. Now let's see what we have. Okay, as usual, we always look at these in across three layers, right? One is what is said in our Vedas and Samhitas and Puranas, what is there in our Vedanga Jyotisha time frame, and what is there in the uh, the later Siddhantic era and the post Siddhantic era, right? Now, in the Samhitas, with respect to the planets, so the first thing is there are not many uh, direct references to the names of the actual planets, which is the Mars, Mercury, Jupiter, Venus, Saturn, and so on. You find a lot of references to the sun and the moon, and the eulogies to them, in the Vedas. However, not much of the other planets is directly referenced, right? So that's the first thing, right? So, for example, you have this Rigveda Samhita 1:105:10, which is it says, "May the five shudders of benefits who abide in the center of the expanded heaven, having together conveyed my prayers quickly to God." So there is an allusion to five entities, right? But they are not actually mentioned directly that they are like the five grahas or the planets, right? And by the way, the five grahas are Mercury, Venus, Mars, Jupiter, and Saturn. Sun and Moon, anyway, they have uh, direct mentions across our scriptures, right? And then, very interestingly, if you look at Rigveda Samhita 10:123:1, it talks about an entity called Vena, right? This Vena enfolded in the membrane of light urges on the germs of the sun and so on and so forth. The sages cherish him at the confluence of the waters of the sun with the endearments like a child. So this apparently refers to the planet Venus, right? What is very, very interesting is the planet as we know it today as Venus. has been recorded as the as with the name Vena, right? Uh, so that's a very interesting, reference that we have had as early as the Rigveda Samhita to something what we call as Venus today, right? And uh, Venus is mentioned as enfolded in the membrane of light. So today, if you discard the sun and the moon, the brightest object that you can see on the sky is the planet Venus, right? So the Venus is so bright that it is in some parts of the earth it is said to cast shadows on the earth, like the moon does, in very dark places. So so Venus is referenced as the one that is enfolded in the membrane of light, and it's called as Vena. We also have references to the Brihaspati, which is also the Jupiter, in the Rigveda Samhita again, right? So Brihaspati, when first being born, the highest heaven of supreme light, seven mouthed, multiform, seven ray, has subdued the darkness. So the next brightest object in the sky after Venus is Jupiter, right? Uh, again, Jupiter is so bright that even with very faint binoculars, you can actually make out the moons of the Jupiter, right? The four moons of the Jupiter are very clearly seen. Uh, so again, Venus and Jupiter, just by your observation, come out as very bright planets in the sky, and uh, their observation obviously has not been missed during the Vedic times, right? And there is one more reference to Brihaspati in the Rigveda Samhita, which says Brihaspati, when it rose, was first visible near the star Tishya. Tishya is what we today call as the Pushya Nakshatra. There's a very a close connection between the Brihaspati and the Pushya Nakshatra, because Brihaspati, from an astrological uh,
It's
context,
exalted.
gets exalted in the Pushya Nakshatra. Pushya Nakshatra itself is one of the very, let's say, benefiting nakshatras. Is considered the one of the best nakshatras to start anything, except doing marriage. That's a different topic altogether. And Brihaspati is also known as a provider of wealth and riches and all the blessings. So it's a very, and that's the reason why Brihaspati gets exalted in Pushya as well. Um, so there has been reference to Brihaspati, Vena, and indirectly to the five shaders of benefits. Right. So one passing comment about the name of the star Pushya, which is called Tishya. So if you remember, the way the months are named is always based on the nakshatra where the Paurnami happens, right? For example, if a Paurnami happens, if the Purnima happens with the moon being in Jyeshta nakshatra, that is the Jyeshta Masa, right? Similarly, if the moon is in Shravana nakshatra and the Purnima happens, that's the Shravana Masa, right? Similarly, when the moon is in Tishya, which is Pushya, and the Paurnami happens, which is incidentally 15 days back, that is the Paushya Masa. Now, uh, in Tamil, the same time is actually called as Thai. So where does this Thai come from? The Thai comes from the another name of the Pushya, which is the Tishya. So the Tishya, over a period of time, morphed into uh, Thai month, right? So it's a very interesting, connection between the, you know, uh, so if you look at the names of the Tamil months, you can very easily correlate it with the Sanskrit terms, right? Like you call it Chaitra, you call it Chitrai, you call it Vaishaka, you call it Vaigasi. But Thai is the one which is not very intuitive. Why is Paushya Thai? Where does it come from? It comes from another name for Pushya, which is Tishya. So it's a very interesting anecdote that I just wanted to mention while we were on this topic. Right? So yeah, so just to summarize, the primary timekeepers are the sun and the moon. References to the five classical planets are not so frequent in the Vedas. However, they are dealt with elaborately in the later works, especially the Siddhantic works. Yeah, so the Vedanga Jyotisha also does not have many references to the five, to the planets, to the five planets, and it's found in the later astronomical works. So, incidentally, you might also recollect they cast Rama's horoscope and Krishna's horoscope based on the astronomical markers provided in the Valmiki Ramayana and Vyasa's Mahabharata, respectively. So even there, you have some references. For example, Valmiki clearly says that Jupiter or Brihaspati is conjunct with Moon in the fourth pada of Punarvasu Nakshatra. Right. So there, only Jupiter is referenced, whereas the other planets, he just mentions it as there are five exalted planets, and with that, we are able to backtrack the positions of these planets into the corresponding rashis that they have, but he does not mention the specific names of the five planets, even in Ramayana. So I just wanted to kind of mention that as well, except Brihaspati. Okay. So that is during the Veda times, right? And Vedanga Jyotisha also does not have much reference. So we directly go into the Siddhanta times, or specifically the Aryabhata time period, right? So what now you come to Aryabhatiya and you have very detailed calculations and references to the different planets, right? So by the time of Aryabhata, astronomers had started making observations. They had started to formalize the computations. And even by the time of Aryabhata, they had reached a very high level of computational, accuracy, right? So Aryabhatta, if you recollect one of our very earlier classes, you we mentioned that Aryabhatta in his Geetika Pada makes references to the number of revolutions that each planet performs in the Mahayuga. So if you recollect, we also talked about the Aryabhatiya system where where we went through how this 577, 53336 revolutions of the moon in a Mahayuga happens, and how Aryabhatta has actually encoded that in the form of a very pithy word, right? So uh, Aryabhatta has used his geometrical uh, calculation knowledge to come up with a number of revolutions in the Mahayuga, and also using that, he has tried to arrive at the sidereal period of each of these grahas, right? And look at these values. They're astonishing to say the least, because they are almost coinciding with the modern day accepted values, which is based on the Newtonian physics, right? You see that the revolutions of the moon, or the sidereal period of the moon, is accurate up to the up to 4 or 5 decimal points, and the margin of error is extremely low. So one of the striking features, even with Aryabhatiya, is that through a course of probably observations and through very careful geometrical computations, they are able to nail down the revolution period of each of these grahas, right? So remarkable accuracy is one of the hallmark of Aryabhata, right? Now, he has achieved this, without the the help of any model optical instruments like telescopes that Galileo had, or the mathematical foundations and the physics foundations that Newton had, relying purely on geometric models that he had in his head, and also with very, let's say, not so sophisticated instruments that they had at their disposal at that point of time. Right? So it's really mind-boggling to to realize the level of sophistication in their thinking to arrive at such accurate values, right? And needless to say, this astonished astronomers who came later. One of them is John Playfair. He was really mind-boggled by the extraordinary precision of these computations, right? I mean, obviously, these precisions cannot happen overnight. So obviously, the hypothesis that it's a continuous process of observation and refinement and challenging the status quo that has led to the precise values that Aryabhatta has come up with. So it shows the way knowledge is gained and sharpened over a period of time. So this the you know the takeaway here is more about the process of acquisition of knowledge and the refinement of knowledge that our ancient astronomers seem to have had, which is really astonishing and which really makes us very proud that we belong to such a tradition where we gain knowledge in a very structured manner and we challenge the status quo. We don't accept anything that is given to us, and we also understand that these values themselves are subject to change. So we come up with newer models, we come up with better observational methods and keep continuously refining this. And this is exactly how knowledge progresses. And we have been doing that very beautifully, in our ancient Indian astronomy. Right? So I think that's the kind of major lesson from these values, right? Now, obviously, the story does not stop here. Uh, Post Aryabhatta, we have another genius called as Nīlakaṇṭha, and Nīlakaṇṭha refines this further in his Tantrasangraha text, right? So he comes up with, he makes more observations, right? And he has come up with a refined values of these revolutions, which further improve the accuracy of Aryabhatiya's numbers, right? So um yeah, so this fundamental refinement became the starting point of a major. So Nīlakaṇṭha now not only refines the mathematical accuracy, right, but he is also now postulating a new planetary model, which we will see shortly. And he again, Nīlakaṇṭha was also a big, let's say, champion of observation, right, and experimentation, and uh, testing the hypothesis with the observations and changing the model based on the observations, the typical scientific process. So he's a very strong advocate of that, right? So he happens to be Parameswara's grand disciple when it comes to the Kerala School of Mathematics. And if you recollect, we did briefly mention about Parameswara, who stayed in the banks of the Nila River in Kerala. I don't know where that would be today. Say, assume it's going to be somewhere in the center of Kerala. And then there is an eclipse that is predicted or predicted to happen in certain months' time, and Parameshwara undertakes this journey, which is at that time a very arduous journey from Kerala all the way till Gokarna, right, which is in the coastal central Karnataka or probably northern part of Karnataka. And in during those days, that kind of a travel was challenging to say the least, because of all the practical difficulties that were involved in going from one place to another and also carrying out the daily rituals that they had to perform and all that. But he did that because he wanted to be in the best possible position to make an observation of a solar eclipse and take the data back and change his mathematical models. And just look at the effort that they have taken to do that and the importance that they have placed on observational astronomy. And we are talking about like the 15th century thereabouts, right? And he has obviously inculcated that discipline into his students. And Nīlakaṇṭha is also a very strong advocate of the observational part of the astronomy, right? So he has not only refined these models, but he is also coming very closely to the Keplerian model, right? Which came much later, in the West, right? And he was the first scholar to clearly deduce that the interior planets, which is the Mercury and Venus, do not actually rotate the Earth, but they actually rotate the Sun. But then he still believed that the Sun rotated the Earth. So it is like it's a quasi-heliocentric model, right? So some planets are rotating the Sun, but the entire system is actually rotating the Earth, right? This is, and we are talking about like 1500 BC or so forth, right? Oh, sorry, 1500 CE, thereabouts, right? And one of the other hallmarks of Nīlakaṇṭha is see, before Nīlakaṇṭha, all the astronomers were relying on mean positions of all these different grahas, right? Whereas, uh, while in the real world, planets do not move in mean motion, right? They move with actual motion. Sometimes they are fast, sometimes they are slow, either in absolute terms or in relative terms, right? Absolute terms because they are always influenced by the gravity of the different bodies that are there. So when they pass closer to the sun, they are fast. When they're away from the sun, they are a bit slow, and so on and so forth. Right? So uh, Nilakanta said provided this exact formula for the derivative of the inverse sine function and used that to calculate the planet's Kalika gati. That is the at that point in time motion of the planet. Right? Now, why is this important? It is important because by knowing this accurately, you can very accurately predict the timing of eclipses, right? Which was important for various purposes, right? So, one of the significant uplift in during Nilakantha's time was the accurate prediction and the timing of eclipses because he was able to calculate the instantaneous rate of motion of different planets, including the moon, right? So that is so Nilakantha, as you see, has taken this planetary theory to the next level from where Aryabhatta himself has made it very accurate, and Nilakantha is actually taking it to a different level and refining it and coming up with new planetary models and all that, right? Now, obviously, all this is raw numbers and science and mathematics and models, right? But the beauty of our Indian astronomy is that there is also a nice system, the language, the Sanskrit language, that is a useful tool to do to produce many of these texts, right? So let's look at one of them. So, for example, Nilakantha, uh, so the moon's node, the number of revolutions of the moon's node. So the moon's node, by the way, is the what we can call as Rahu and Ketu today, which is the point where uh, the plane of the sun and the earth crosses the plane of the earth and the moon, right? Because the moon rotates the earth in a plane that is different from the plane that the earth rotates the sun. So these are two different planes. And wherever these planes intersect, there is a node, right? So there's a rising node and there's a falling node, which we call as Rahu and Ketu respectively. So the moon's node, in this case, it should be Rahu. And the number of revolutions is calculated as 23, 23, 100. But how does he actually encode this in Tantrasangraha is a very interesting part, right? So let's look at that. So to do that, you need to understand what is called the Bhuta Sankhya system. So what is the Bhuta Sankhya system? It is a very efficient way of representing, like large magnitude numbers, right? Like the ones that we are seeing, right? Especially in subjects like astronomy where it is needed, right? Similar to Katapayadi system, right? Uh, so Bhuta Sankhya literally means Bhutanam Sankhya, right? Which is the number associated with beings, right? So how does it work? It uses words instead of numbers uh, to represent the numbers, right? So these words are very commonly used in Sanskrit. It is part of the common knowledge, and it is, it's like if you say the word, you clearly understand what is that word, right? So, for example, zero. So, if you come across the word bindu or nabhas or randra, right? So, randra is literally a hole, right? So, it's the hole is like a nothing, zero, right? So, that is zero. Bindu again is a dot. A dot is like nothing, right? It's the 0 point. So, that's zero. So, similarly, if you say mukha, So Mukha is face. There's only one face. So it corresponds to one. Bhumi, there's only one earth. So that corresponds to one. Similarly, Netra, there are two of the pair of eyes, so two. Ayana, there's Dakshinayana. So they have come up with a system where they use common Sanskrit words to represent numbers, and then they align those words in a certain sequence to convey that large number, right? So that's the essence of the Bhuta Sankhya system. So Tithi, whenever they want to represent the number 15, you can just say Tithi. Whenever you want to represent the number 64, you just say Kala. There are 64 arts. So you just say Kala, and so on and so forth. So that's the idea. So using this, how does he convey the revolution of the moon's node, right? So which is represented by this phrase called Thakha Rama, Thakha Ramara Dash, the Ramaradashvina, right? So as you see, Kha, so he splits it as Kha, Rama, Radha, and Ashvina, right? And Kha is a whole. Rama is the Ramas, right? Radha is it, Radha means teeth. And Ashwinaha is the Ashwini Kumaras, right? So there are always, so the Ashwini Kumaras are the celestial emergency responders, the celestial 911, right? So there are two of them. And whenever there's an emergency, they are there to help you. That's the idea behind the Ashwini Kumaras, right? So there are two of them. So it obviously means two. So now you just convert that to a number, right? So whole is a zero, no? Is zero. There are three Ramas. So there is, of course, Parashurama, there is the Sri Rama of the Ramayana, and then there is Balarama during the Mahabharata. So there are commonly understood as three Ramas. Teeth, obviously, 32 teeth. Then Ashwini Kumaras, there are two Ashwini Kumaras. And then you just, reverse the order. That's the practice that they followed. And then lo and behold, you get the number, right? So Kakarama Radashvinaha is nothing but a code word for 232300. And rather than conveying it dryly, they've just used this very beautiful system of encoding. And then this will be part of a shloka, which is used to convey the number of revelations of the moon's node. And of course, that shloka itself will adhere to the standards of a typical shloka with all the meter and grammar and all that, aligned in a proper way. So this is a small detour from what we're actually doing, but I just thought it was interesting and just thought I should share that. So we have now seen at least two systems of encoding that are ancient astronomers. Aryabhatta system, which is his own system, where certain syllables represent certain numbers and certain exponents. And then there is the Bhuta Sankhya, which is very commonly used across many of our texts. And this is the Bhuta Sankhya system. So, incidentally, you would have heard about this Madhava again from the Kerala School of Mathematics, who is credited with the with with the with to have calculated the value of pi to up to 13 decimal places, right? Now, incidentally, that has also been encoded using the Bhuta Sankhya system, right? So another usage of the Bhuta Sankhya system is this very popularly known verse from Madhava for the calculation of the pi. I will not go into the detail of it. You can probably refer to it offline and see how beautifully uh, the different values after the decimal points of pi come as a result of the sloka that is written by Madhava by applying the Bhuta Sankhya system. So I'll just leave it for the for offline reading, right? So let's go back. So Nīlakaṇṭha has, so similarly all these numbers have also been encoded using the Bhuta Sankhya system. Otherwise, it will just be very difficult to read a text with all these numbers written in their original way, right? Um, okay, now we talked about quasi-heliocentric model of Nīlakaṇṭha, right? So he is proposing a major revision uh, where the five classical planets orbit the mean sun, and the entire planetary system orbits the Earth, right? So this model closely resembles the Tychonic system, which was proposed by Tycho Brahe, who is a famous astronomer. But it's just that he did it earlier than Tycho Brahe by about a century, right? So that's the point that is not often stated enough. So prior to Tycho and Nīlakaṇṭha, there was this Aristotelian model, which was probably in vogue for a very long time, 350 BC. It was founded. A very plain Earth being at the center, everything moves in perfect circles around it. There is no nonlinear motion. Everything is moving in perfect circles at average rate of velocity and all that, right? But then Tycho proposes a different one. See, he says Earth is still at the center, so we are still there. We are still geocentric, but largely. But then the planets, especially the inner planets, the Venus and the Mercury, go around the sun, and the sun goes around the Earth, right? And the other planets, which is the Jupiter, Saturn, and Mars, are going around the mean sun, right? So I think that's the kind of model that Tycho came up with, but Nīlakaṇṭha has come up with this about a century earlier than that, right? So yeah, very so. The only thing is, Tycho assumed that the sun to the planet distance was constant, whereas Nīlakaṇṭha, notes that even that distance, they don't move in perfect circles, but it rather more of an elliptical kind of a motion. So the sun-planet distance is always variable, and then uniform circular motion again assumed by Tycho, whereas Nīlakaṇṭha, like we saw, is assumes that it doesn't have a uniform motion, but it slows down in some parts of the orbit and it speeds up in certain parts of the orbit. And then there are other, refinements uh, over Tycho. I mean, you should not say refinements, the discoveries that were made by Nīlakaṇṭha before Tycho Brahe actually came up with and kind of popularized this model, right? And like we discussed earlier, Nīlakaṇṭha has tuned these values based on the observations that were possible, at that point of time. So again, this is a testament to the wonderful, capability, mathematical and observational capability of our ancient Indian astronomers, right? So moving forward, there's this concept of Ahargana, right? Ahargana is literally it means ahaha. It's a combination of the words ahaha and ganaha. Ahaha is aha is a day, gana is a collection. So it's a collection of days. So it is a very it's a very linear system where it's the total number of mean civil days that have elapsed from a fixed starting point, which is typically known as an epoch to a desired date. So you can calculate Ahargana for any given date, say for today or for tomorrow or for whatever time it is, right? So by the way, when we mean civil days, what we actually mean is a sunrise. So the number of sunrises is the number of civil days, right? So it's a very simple concept. And so the Ahargana calculates the number of days from a certain date, and that date typically is the beginning of the Kaliyuga, right? If or in modern days, right? So if you look at the classical texts like Tantrasangraha, they have given a very detailed procedure for exactly calculating the number of days that have elapsed, number of civil days that have elapsed since the beginning of the Kali Yuga. And it is on the basis of that we are able to very accurately pinpoint the longitudes of the planets, and it kind of forms the basis for our entire Panchanga system, right? So, uh, yeah, I mean, so Ahargana, in a way, the Ahargana calculations are the foundation of our Panchanga system, which we use it very extensively for our day-to-day practice, right? Uh, So what is Ahargana? Ahargana is a engine for planetary positions. It's the primary input for determining the mean longitude of any planet, uh, which is the basis for Panchanga, astrology, and everything that we have. Uh, and exact mean planetary position at sunrise. It gives the exact mean planetary position at sunrise. So when you calculate the Ahargana, you don't have to have complex calendrical units like years, intercalary months, and tithis. It just kind of condenses everything and gives it as one single number, right? So that you can clearly uh, have a timeline for for the astronomy, and it is also used for determining the weekday at any given point of time, right? Uh, so, in other words, the Hargana is like the number of miles that you see in your car. That is Agar. It's a master odometer for the solar system, right? So it says the number of days since the beginning of Kaliyuga, and then it counts every mile or every day since this journey began and gives it as one whole number, so you exactly know where you are with respect to the beginning of the Kali Yuga. Right? So that's the concept of Ahargana, and the practical usage of it is obviously it is the basis for the longitude calculations for all the planets. Now, that's a very detailed procedure for calculating the Ahargana, and thankfully for all of us, I will not be going into the details of that. It's kind of too too intense in mathematics. I'll spare that for this course at least. Maybe in a future course we can deal with it. But the rough formula for that will be to first look at the number of solar years that have elapsed since the beginning of the Kali Yuga, convert it into the lunar months, and then add the number of Adhika Masas. And then, because we always have to do this Adhika Masa adjustment, right? To synchronize between the lunar calendar and the solar calendar. And then add the lunar months that are elapsed in the current year. So if I'm calculating Ahargana for today, right? In this year, we have had, I think, 10 lunar months that have elapsed, right? 10 or 11. So we have to account for that, and then convert the total lunar months that have elapsed into the tithis, and add these elapsed tithis to the current lunar month, and then convert the total tithis into civil days. So it's a very elaborate formula, and these are some snippets of the Ahargana calculations that we did when we were in the Rajvedams class. So this is particularly done for June 22nd, 2024, which happens to be a Jeshtamasa Paurnima. And, you can go, I can share, these calculations with you, if you're interested. But once you have calculated, you arrive at this odometer number, which is 1872018, and you have to do some small adjustments here and there. You get this number. Now, based on this, you are able to compute the mean longitude of the different planets, right? So sun is at 65 degrees, moon is at, so these are the numbers that you would see in a typical astrology software or a panchanga, and this is how it is actually calculated behind the scenes, right? And then you then, also induce what is called the desantara correction, because because uh, the planet the planetary adjustment that see these all these are with respect to the Ujjain as the place, right? So if you are further west or further east, you might have to do some small longitudinal correction by a few degrees. So that is also included. So you can see how accurate and how refined these numbers are, and finally you arrive at the exact planetary positions for each of these planets, right? So that's how the Ahargana is actually calculated. right? So yeah, I think uh, that should be it. Right? So there are some references, or you can refer to these. There is a very interesting Bhuta Sankhya list if you are interested, where they have given some common words that can be used to encode numbers in very interesting list, if you want to go through and why it corresponds to that number is a very interesting, mental exercise that you can do. Hasta, there are two hands. You can just, Chakshu again is eyes. Paksha, the Krishna Paksha and the Shukla Paksha. So you can just go through that. It's a very interesting list. Um, and it's not exhaustive, but I think it kind of covers. Now, the good thing about the Sanskrit language is it has it's a very rich in vocabulary, right? So, for example, if you take the word water in English, water probably has I don't know, some 100 different words corresponding to water in Sanskrit, right? So, and this just gives you much more permutations and combinations to use any appropriate word that fits into a shloka without violating the grammar of that shloka, or the what do you call, the conditions of that shloka in terms of the meter and everything, right? So I think that's the beautiful way in which we have blended the scientific concepts into the beauty of the Sanskrit language, and how Sanskrit as a language beautifully lends itself to to these things is also another astonishing aspect of our entire Indian knowledge, right? So you just want to go through this if you have further interest in this subject, right? And yeah, I think some interesting YouTube links talk on Indian classical astronomy where there are some planetary references, and then um, how there's a talk on how Aryabhatta, the calculations that we did over 1,500 year time frame, or probably more, got us close to the modern precision. So you can listen to it. And then Tantrasangraha is literally a magnum opus of Nīlakaṇṭha. It really looks like a modern day, like a Resnick Holiday, or any kind of math textbook, astronomy textbooks that you can, or physics or maths textbook that you can think of in terms of various geometrical theorems and calculations and all that, blended with the beauty of the Sanskrit language. So you can go through this book of Tantrasangraha of Nīlakaṇṭha Somayaji as a further reference, right? So I think that is basically what I wanted to convey. I have not kept any, tough assignments, but maybe you can just say, uh, just if you're interested, the number of revolutions in Jupiter is this particular word that has been used by Nīlakaṇṭha. So you could take a shot at why this corresponds to that number for Jupiter, which is basically 364180. So why did Nīlakaṇṭha use this particular word to represent that 364180 number? Is an interesting exercise you can do. Again, not mandatory, but highly encourage that you do it. Right. So I think with that, probably we can wrap up, today's class. I've not kept it very detailed. We could have probably had an entire class on this calculation of Ahargana, but just didn't want to go there in this particular course. We just wanted to be familiar with what this at this point of time, and we can hopefully go into the details of this in a future course, right? So with that, I just take a pause. Any questions, any observations, any suggestions? Welcome.
I just wanted to add that if you just look at the works of Aryabhatta and the works of Nīlakaṇṭha Somayaji, and it's you see that the whole thread of refinement going. So it's like, the never knowledge is never static. Knowledge is always dynamic. It's always moving, and there's always refinement, and that is such a profound aspect of our knowledge systems, whether it's astronomy or mathematics or medicine or anything, but it is always evolving, and there is always addition, there is always refinement that is going on, which is kind of reflective of the science advancements that are going on right now. However, what is to be noted is that there was no bias, and you will be very hard pressed to find a bias. So, yeah, even now, in many of the refinements we see, there is always a little bit of bias that exists within the scientific field. That, whether it's bias towards a certain theory, or whether it's biased towards a certain ideology or whatever. So that is very completely absent in our knowledge system evolution.
Yeah, absolutely, Ajay. Thank you very much for adding that. It just can't emphasize that enough. It's it's really a hallmark of our Indian knowledge systems in general and astronomy in particular. Yeah. Um, yeah. Um,
I
any
just
other?
had a quick question on the coding system. I think it's very interesting. And I also had attended the Katapayadi system, which just takes the first letter of different words to encode different messages. But my question was, because these words also carry other meanings like we also saw Rama and things like that. They carry meaning outside of this code as well. Now, when these scholars are writing or composing these verses, how would, if it's just taken out of context, if I don't know that Nilakanta has written it in this context and read it separately as a shloka, there's a very good chance that I will probably misinterpret the whole thing or read a different meaning into the whole shloka. So is it not adding to the confusion in some way?
Yeah, I would agree to that, right? And see, again, much of our Indian texts suffer from this interpretation problem anyway, right? I mean, so yeah, I mean, that problem is definitely there. I will, it won't be, I won't be honest if I said that that is not there. But in my knowledge, there seems to have been, I don't know, some kind of accepted, values for some of these. For example, Rama has always been three. Probably, you look at different texts and, maybe wherever there was three to be mentioned, they mentioned it as Rama, So there seems to be some kind of a tacit understanding behind the scenes that also seems to be there. But yeah, completely agree. It is not foolproof. It is subject to interpretation. Yeah, that's how I think as well, Dr. Rashri, right? But at the end of the day, I think they don't look at it as a very rigid system. I think they probably also apply a little bit of practical common sense and take the value that actually makes more practical sense and kind of go live with that. But yes, it is subject to misinterpretation. I completely agree with that.
Has this been used by other scholars other than Nilakanta also?
Yeah, definitely the Kerala School of Astronomy seems to have used it widely. Even beyond astronomy, it looks like it has been very widely used, Doctor. I can probably provide some references outside of astronomy, but definitely it has been used a lot in Kerala School of Astronomy for sure.
But it was
Probably
created by Nilakanta, or was it already there?
no, no, no. It was I don't know who created it. It was a widely used system. Just like I don't know who created Katapayadi. for that matter, right? Uh, it's yeah, but it seems to have been prominently used, understood, kind of an accepted standard of encoding that has been used across, at least Kerala School of Astronomy, if not, the larger Indian subcontinent at the point of. But it was not invented by Nīlakaṇṭha. Aryabhaṭa invented his own system, but Bhuta Sankhya does not belong to Nīlakaṇṭha. Yeah, I
And
can provide
I
more
think,
information on that, Doctor. Yeah,
yeah, in general, I think there are many aspects of language which have been used and are understood by people many times in a particular school or a particular community or a particular era, and then it has the main misinterpretations are occurring from people who are completely devoid of that knowledge, completely misunderstand or not from the community. For example, many Western scholars or so-called scholars have completely misinterpreted many aspects of the Vedas or many aspects of astronomy or many aspects of mathematics. Uh, I mean, is to actually prove that all this knowledge did not exist. So that is a very frequent tool that's used by people who willingly want to distort this knowledge that existed. But you're right; it can be very easily misinterpreted, and that is unfortunately has been the case.
yeah,
The classic example is the Varna system, which is made out to be a Jati system or the caste system
Sure.
on which
Sure.
the whole society is divided. Leave alone the Westerners, when we Indians fight amongst ourselves, language, caste, Jati, this, that, This is a typical, classic example of a day-to-day life, this interpretation.
yeah. Cool. So I think that is basically what I wanted, to cover in this class. It was short, concise, and quick, and we didn't elaborate it a lot. But yeah, hopefully there's an opportunity in the future to go deeper into the subject. Any further
Yeah,
questions, comments, suggestions?
I had a small uh, clarifications, Motherji. This Ratha Saptami is coming up. I know maybe during Varahamir's time, it was all coincided with the Uttarayan, the solstice, the Uttarayan, Ratha Saptami too. I don't know. I'm presuming, but now
Hmm.
they're all moved away. Solstice happened on 21st, 22nd December. Sankranti yesterday, day before
Hmm.
yesterday. Ratha
Hmm.
Saptami is coming up. So if you can throw some light on this Ratha Saptami aspect also for my clarification,
Hmm.
if it's part of it.
Yeah, see, Ratha Saptami is, very close to the Uttarayana time, right? It is, I think in my knowledge, it is different from Uttarayana. It's not the same as the beginning of Uttarayana. But what is commonly understood in practice is where the northern movement of the sun towards the northern part of the sky becomes very obvious, So until Uttarayana, the sun has moved south, right? And then technically after Uttarayana, it has actually started moving north, right? But then during Ratha Saptami, you clearly start seeing, our ancient astronomers are not astronomers, the ancient Indians have started seeing that the sun is now moving towards the northern part. So that particular time or that particular tithi has been chosen as an auspicious tithi, and it has been used to mark the northward movement of the sun. So that is the significance of Ratha Saptami. It is different from Uttarayana. the actual point of Uttarayana, and that is the, it's just a practice that they have followed, based on that. Right? That's my understanding. Yeah, I think they would have increased that the length of the day is clearly now more, than the length of than the length of the night, starting from that particular tithi, and they have just fixed that tithi. Is what I think. Yeah, yeah.
Yeah, thank you,
Yes,
Krishna.
I think that is yeah.
So, as
And the number seven,
Madhuji,
the number seven
sure.
is also closely associated with the sun, right? So the sun is always symbolized as the, like a chariot with seven horses. I think there are different interpretations. It's like some say it's the seven colors of the rainbow, or some say it is the 7 days of the week, or it is the seven chandas, or what. So I think they have taken this northern movement of the sun. They have taken that number seven, and then probably they have that Ratha Saptami. But that is the significance. Nothing very deeply astronomical about it, in my opinion.
Okay, thank you. Ajay was making a
So,
point.
yeah. So as Modi was saying, basically next week we will try and summarize all the different aspects, and there are many different things that we talked about in this 18 weeks, and so we will try to summarize all those things together, and both of us will try to finish this the summary in that the first hour or whatever, and then in case you have any questions, any clarifications, any doubts about all those different things that we've taken up, please feel free to ask, and we will extend this session if required.
Yeah. And just a request from Ajay and I would be, for all of you to kind of reflect the last 4 months of what we have kind of gone through and discussed. And if you think that there are any major gaps in your understanding, because this is supposed to be a basics of Bharatiya astronomy course, we just want to make sure that the basics are established to a certain degree. So if you think that has not happened in certain parts of the course and you want some more clarity on that, maybe we can focus on that a little bit, or we can find a way to redress that, So that would be our request. But like Ajay ji said, we will summarize the course, and hopefully we can go back with a broad understanding of the different concepts and terminologies, which will help you go deeper, at later point of time. So I think that's the idea for the next class, right? Okay. With that,
Okay,
I think we can call an end for today. Thank you very much for attending.
thank
Hoping to
you.
see you in the next class. And dhanyawad. Namaskara.
ధన్యవాదములు.
Yeah.